Hello there, I'm Auhona and I'm thrilled to welcome you back to my channel. In today's video, I'm going to take you on an exciting journey through a project that I had the privilege of creating during my internship at Oxford University. It's all about the remarkable Pulse Prophet, so stay tuned and learn more about this project. Now I'm going to share my screen so that you get a gist of this project. Here we are. So here you can see there is an introduction to the project. So the project is about an AI app that can predict 42 diseases using symptoms, and this can help the society by early disease detection, individual health management, and increased healthcare accessibility. The reason for choosing this project is that I have a keen interest in learning deep learning, as I've not really learned and have hands-on exposure on this in my previous projects. So yes, I was interested to do this project because of that. And then accurate disease prediction. This can forecast 42 diseases using machine learning models such as SVM, random forest, and naive Bayes. And then you can do swift malaria detection. And this is done using convolutional network CNN model, Keras mainly, and informed updates, so you can get news articles about science, health, and technology. So that's an advantage about this project. And here are some of the social media links. So I will be adding the GitHub link under this video, and obviously this is a YouTube video, so you will always have the link to this as long as you're subscribed to my channel. And now we will be seeing how the project is. So I have three files for this project. One file is for the front interface, and then I have two more files. One is for malaria cell detection and one is for 42 disease prediction. And here are the many different functions. So these functions are related to detecting malaria. This is the GUI part, and I'm using Streamlit for this, but I've also integrated HTML in this project because Streamlit really didn't give me all the choices that I expected it to give me, so I had to use HTML. And there is a preprocess function that resizes and normalizes the input image that the user gives. And make prediction one, that function performs the actual prediction. The final malaria prediction process, that function is for processing the sample image to detect the malaria. And the detect malaria cells function, it processes the uploaded images and it returns a result which indicates if the malaria cells are detected or not detected. And then here we have the image to base64 image, which is converting the image to base64 format for displaying it. And then here we have, these are the main libraries that I used. So GNews client, Streamlit for the GUI, base64 for using this format. Then this bytes and base64, they kind of work together, doing the same type of work, which is the display. And then a GNews client is for getting the API and all for news, for displaying news. And then pill OS is for path, pill is for displaying the image and resizing it, normalizing it, all those things. And then CV2 is also for detecting images. And then we have NumPy, and NumPy is for doing normal mathematical calculations. And then Keras also is here because we are doing malaria cell detection, and that is involving deep learning. So now that we go down, we will see more. So here we can see that I have used the pickle format .pkl, which is why I have imported pickle, and pandas I have imported that so that I can do normal EDA on my file. But here I've not done EDA here, but that's what usually I use pandas for opening the file, reading it, etc. Now you can see here I have opened the files here. I have also labeled and encoded this file, and here is again for pre-processing the input data. Then here is a dictionary that maps the disease numbers to disease names. So the prediction, it comes in numbers, but then I had to predict it to names. So here we are. It's a full pick list. And then we have the combined prediction of all the three models, and then which returns the disease name. And then this is the save uploaded image, so you can upload your image here, and that's how users will do that. And then the malaria detection page, which is basically the GUI of the malaria detection, how it will work, the different buttons, and everything is here. And then we are going to the part, so these are all the symptoms that are also there in my data set for 42 disease prediction, my bad. And here we are finally to the part which fetches and displays news. So that's where I also use the GNews client. And you can get news from different countries as United Kingdoms and India, United Arab Emirates, Japan. And if you guys want any more countries, let me know down in the comments section, so I'll add that as well. And then this is for the main layout of the page, what will the background be, etc. And then here you can see I've used a little bit of HTML. And then here you can get the homepage content. And when you write this code, it means you run this full code, it will initiate the application. So that's the main part for the Streamlit. Now we are in the 42 disease prediction, how that worked. So mainly we use the sklearn library, the pandas library, and the pickle library to read the files. And here you can see we read the files, then we encoded the data, then we had prepared the training data, then we split it into test and train data, then we fitted those data into SVM in naive Bayes and random forest models. Then we open this is in writing format, is WB, so this you can write, you can change it, that's what I mean. And then this is RB, as you can see, that is RB, and you can read the full file with that. And then we have preprocessed the data and then function to make the disease prediction. So here we have also combined all the three models to get the prediction. The one bad thing about this model is that it's an overfitting model, and it has 100% accuracy, which is why it's overfitting. That's the only thing. And here you can just test out the data. So this is an example usage. And then we have the malaria cell code detection. So here are the necessary libraries, which is Keras, as I mentioned before. And I've used Keras so that I can import different layers such as maxpool, conv, dropout, flatten, dense, but I didn't use batch normalization. But I just imported it just in case if I needed to. And then here you can see I've defined the paths, and then I've plotted some graphs, and then I've set the image dimensions, because my data set, it has some 20,000 images, and I wanted to make all the images of the same size, same dimensions, so that I can actually train it properly without getting any syntax, any errors, not syntax like that. And then here we can see the CNN model, and there's a model summary. And then you can see that the epoch range is here, which runs, and finally saving the model. So that's about it for the code, and always you can access it in GitHub, so you can go forward there to learn them. Now I will be showing you how the app looks. So here we are. We have four main pages, and one of them is the home page, as we can see right now, and 3 pages are one is for 42 types of disease prediction, one is for malaria cell detection, and one is general health information. So let's now see how it predicts. There we go. Now we can see that There are many symptoms over here, variety of symptoms, and let's take random ones, maybe from the beginning and the end. Just taking random ones. Okay. Okay. That was a prediction. Acne. What did I take? Blackheads, pus-filled pimples. Oh yes, itching and skin rash. So obviously it is a skin-related problem. Okay. So yeah, we have acne. So the prediction is more or less right here. And we can go ahead and see the malaria cells detection. This one is not an overfitting model, but it does have a high accuracy, so it might not be, but it works more or less fine actually. Let's see. Mm, let's take one random image. Let's just take this. This. And then open it. And then detect malaria cells button. And then the app shows you the picture that you have selected. And malaria is detected in this cell. As we can see, it is parasitized. It's a parasitized cell. And last but not the least is the latest health articles and news. Let's see how this looks. So here we are, news for science in United Kingdom and India, as I mentioned, the different locations, and then they give you the news articles link. As you can see, this is news.google.com, so it's a Google News that I'm using here. Then we have United Arab Emirates, Japan, United Kingdom again for health, India again for health, United Arab Emirates, Japan again, and then there we go. So for in today's video, that's all I wanted to show you, and this is how I wanted to conclude for today's video. I hope you enjoyed this video thoroughly, and I'll be catching you in the next video. So thank you everyone.